Hello and welcome to GCSE Chemical Changes with Mrs Castanera. We're on lesson 10, Electrolysis half equations, which is a higher tier lesson. So only students who are taking higher tier science will want to do this lesson. If you're doing foundation tier science, then you'll need to move on to lesson 11. So our key words for today's lesson are ion, electrode, anode, cathode, electrolyte, molten, solution, and redox. You should know quite a few of these already. So we're going to start by doing the knowledge check on page 15. There are 8 questions. Please pause the video whilst you do the questions. Okay, so let's go through those. State the type of current used in electrolysis, so that's DC or direct current. The name of the positive electrode is the anode. 2 ways to make ions free to move in a compound is heating or melting, and dissolving or putting it into solution. You'd have a mark for each. The name of the negative electrode is the cathode. So the electrons are found either in the current or in the wires or electrolyte, depends on how you've put it. So either of those answers is correct, you just need one. The liquid that has free moving ions is called electrolyte. The lead bromide is a binary molecule because it's only made up from 2 elements. And inert electrodes are used because that way they don't react with the products of electrolysis. Okay, so there are 9 marks there because we had 2 marks for question 3. So give yourself a mark out of 9, please. In today's lesson, we're going to be able to write balanced half equations for the reactions that occur at both electrodes. So that's both the cathode and the anode. I'm going to write a note to say that. Redox and electrolysis. Make sure you're highlighting where I'm highlighting and writing in the notes that I put in. So electrolysis includes the oxidation of the non-metal ions at the anode to become non-metal atoms, as well as the reduction of the metal ions at the cathode to become metal atoms. We can show what is happening to these ions by writing an individual equation for each one, and that is called a half equation. And the symbol for an electron is E minus, okay, and the minus is above it, so lowercase e minus up there, that is the symbol for an electron. Okay, so what we're going to do now is we're going to watch this video on YouTube. It's a few school videos, so that's the people who make the video, and the title is What Are Half Equations? So you can either go to YouTube and look this up by typing this in, or you can, if you've got a digital copy of the booklet, you can click on this link. Okay, I'd like you to make notes in the box below of the key components of the video and the key things that they are saying. So pause the video whilst you watch that, please. So hopefully you have a better understanding from the video now. We're going to look more into writing half equations. And these are the equations that describe what is happening at both the anode and the cathode. So a half equation shows us what is happening to an atom or ion in terms of losing or gaining electrons. Okay, there are some very simple steps to follow. First of all, you're going to write the ion. Okay, and then you're going to draw an arrow to the right. So in the very same way that you draw the reactants in an equation, and the arrow to the right tells us that something's happened, it's changed, and then on the other side of the arrow you get your products. So in this case we're going to start out with the ion, the arrow happens to show that something has changed, and then we write the atom or the molecule without the charge on the right of the arrow. Okay, so at this point you've got your ion, your arrow, and your atom. Okay, so this is what it should look like so far. Ion, arrow, atom. So now you're going to need to balance the equation. Now that's not always required, but sometimes it is. It might be that you have one ion makes an atom, but the atom is diatomic, such as O2, in which case you would need 2 ions to make one diatomic atom. That's an example of how you might need to balance it. Then you will need to add or subtract electrons depending on whether you start with a negative or a positive ion. Okay, I'm going to go through some examples to show you this. So we're going to do an example here from lead bromide. So write the ion and draw the arrow. Well, here is our ion, Pb2+. It's a 2+ ion, and we've drawn our arrow. Then we're going to add to the next line of this equation the atom that it turns into, which is Pb for lead, and that doesn't have a charge because the atoms are neutral. So now we're going to balance it. Well, this one's already balanced because it's one ion turns into one atom. Now what we need to do is add or subtract the charges. Now in this example we have to add 2 electrons to the lead ion for it to become a neutral atom, because our lead has 2+, so we have to add 2 lots of E- to cancel those out. So 2 positive charges. Adding our 2 negative electrons, which have negative charge, is going to be what gives us our neutral, because there's nothing up here, our neutral lead atom. Okay, so we're going to show the bromide now from lead bromide, because that was just the lead. This is how you get lead from lead bromide, and this is how you get the bromide part of from lead bromide. So we're starting out with our ion, which is bromine, and we're drawing our arrow. And bromide, the atom, is Br2, it is diatomic. Okay, now to balance this one, because bromine is diatomic, here we need to add a 2 in front of the bromine. In fact, it's better if it's all in one line like this. Okay, so we'll cut that out and we'll put it here. So 2 bromide ions. Okay, and it does look like a very large R, but let's turn that into Br-. Okay, it's just how it's written. Okay, that makes it more clear. So 2 lots of negative bromide ions. We've got our arrow to tell us it's changed into a diatomic bromine where there are 2 of them together. Okay, now because we have our 2 bromines, okay, and I'm going to do the same thing I've done to the others here. So I'm going to turn that into, there we go. So 2 Br-. Now, because this is a negative charge and we can only add or take away electrons, we've got 2 negative charges because each one is just 1 negative, and we've got 2 electrons which are also negative. So we have to subtract the electrons, we have to take them away, because only electrons can move. You can't move protons, for instance, because they're stuck in the middle of our atoms. Only electrons can move. So we're going to ditch 2 electrons from our bromine, from our bromide ion, and that's going to turn it into diatomic bromine. Okay, so we've subtracted our 2 electrons from the bromide ion to become a neutral atom. Okay, so what I would like you to do now is have a go at learning activity 1, writing half equations, okay? So our first example here is zinc chloride. So we've got zinc chloride is ZnCl2, and we're going to do, the first one's going to be an example for zinc. So here's our zinc ion. Okay, so we're going to go through the first one together. Largely because there's a couple of interesting errors here. So we have this lead that should not be in there. I'm not quite sure what's happened there. So I'm just going to cross these out. You can either do something similar, or you can change it, or you can just rewrite it out elsewhere. So write the ion and draw the arrow. So the ion is here for us. We need to add our arrow in. Okay, then write the atom or molecule. So the atom or molecule this time is zinc. It's just 1 atom. We're going to balance it. Well, that's balanced already because there's 1 zinc and still 1 zinc. Then we're going to add or subtract the charges. So we've got zinc 2+, and then this is positively charged, so we're going to have to add some electrons, and we have to have 2 electrons, 2 lots of E-, okay, because there are 2 positive charges here, so we need to get rid of both those positive charges by adding 2 electrons, and that is going to turn into zinc. Okay, so make sure you've got that written out and corrected. I apologise for those errors in the booklets. And then what I want you to do is have a go with the next one, which looks to be in a much better situation. You can pause the video after the first one, or you can continue on if you're confident and do all 5 of the ones that remain. Okay, you can do one at a time, pause the video and check each one individually if you like. So if you pause the video now whilst you work through however many you plan to do, and then you can go through them with me. Okay, so let's go through this first one. So write the ion and draw the arrow. Well, we've got our ion is Cl-, so you can have a mark for that, and drawing the arrow. So you need to have done both, okay, to get the marks. There's 1 mark for this line. Write the atom or molecule. Well, there it is, Cl2, so you can have a mark for that line. Balance it, well, it's 2 lots of Cl minus, because Cl2 is diatomic, so you have another mark for this line. And lastly, add or subtract the charges. Well, you've got 2 Cl minus, take away 2 electrons, gives us Cl2, so you can have a mark for this line as well. So give yourself a mark out of 4, please. Okay, so pause the video if you haven't done the next one, but we're going to move on to the next one. Make sure you've got all the corrections and you've got that fully correct yourself. Okay, so let's go through the next one. Hydrogen ions, that's H+, to make the hydrogen molecule H2. Okay, so we're writing the ion, it's already written for us, and we're drawing the arrow, so that gives us a mark for drawing the arrow. Write the atom and molecule, that's H+, make sure you've also put the arrow in, and that gives you another mark. And thirdly, balance it, well, it's 2H+, it's going to turn into H2, because H2 is diatomic. There's our third mark. You'll need to have then add or subtract charges, so 2H+, plus 2 electrons, because they're negative charge, you've got to add those together. So you've got to add 2 negative electrons to 2 positive hydrogen ions to get a neutral H2, and there's your fourth mark. So give yourself a mark out of 4, please. Okay, so if you want to pause the video before we move on to the next one, you can. Otherwise, we will move on to copper. Okay, so copper ions, that's Cu2+, to make copper atoms, that's just Cu. So first of all, write the ion and draw the arrow. Well, you get a mark just for drawing an arrow. Write the atom molecule, it's Cu2+, so you get a mark for doing that. Balance it, or Cu2+ turns into Cu because it's a single atom, turns into a single atom. And add or subtract charges, well, it's a 2+ charge, so we have to add 2 negatively charged electrons, because those are oppositely charged, to make copper on its own. And again, that's out of 4. Hopefully you are improving on your score each go. If not, then make sure you're checking for errors in your next one. Make sure you've got all the corrections down before we move on. Now, if you want to have another go or have a go at oxide ions, the next one, oxygen, before we move on, then pause the video now so you can do that. Okay, so we're going to go through that one now. Oxide ions, that's O2-, to make oxygen molecules, which is O2. It's very important to notice the difference between the 2's here. This is 2- at the top as a negative charge, and this is 2 at the bottom to show that it's diatomic molecule. This is 1 atom, this is 2. Okay, so write the ion and draw the arrow. Well, O2- is the ion, and the arrow is in there, so you do both of those, you get a mark. Write the atom or molecule, well, that's been done for us, so literally this time you literally get a mark for writing the arrow. Balance it, well, it's 2 lots of O2-, which is 1 atom of oxygen with -2 charge, turns into a diatomic oxygen molecule, which is 2 atom molecules together, 2 atoms together of oxygen, creating a molecule. And then add or subtract the charges, so we've got our 2O2, and this time we've got to take away 4 electrons because it's got too many electrons, so we have to subtract electrons from this to turn it into a neutral atom of O2. That was a tricky one. Make sure you've got any corrections you need to make there, and pause the video if you need to before we move on to the next one, which is aluminium. Okay, so we're going to go through aluminium now. Write the ion, which is written for us, and draw the arrow, so you get a mark for that. Write the atom or molecule. Well, again, that's been done for us. So Al3+ turns into Al. Okay, so this is just an aluminium atom with a +3 charge, turns into just an aluminium atom that's neutral. Now we're going to balance it. Well, it's 1 atom turning into 1 atom, so it is balanced. And lastly, we're going to add or subtract charges. This is the tricky part. So it's a 3+ ion here, so we need to add 3 electrons to that. So 3 positives and 3 negatives are going to cancel out to make neutral aluminium. So we're going to add our 3 electrons to make our neutral aluminium. So again, give yourself a mark out of 4. Same on the previous one. Okay, so we have done 5 of those, 6 if you count the one we did before. We're going to just count the 5 that we did on our own. So give yourself a mark out of 20, please. Okay, so we're moving on to learning activity 2, describing the electrolysis of ionic compounds. So for each of the examples below, there are several of them, you are going to include the following: the name and chemical formula of the products, the atom economy for the metal in each compound, and the half equations for the reaction at the anode and the cathode. So that's a lot of work for each of these. So we're going to do the first one together as an example. So this is zinc iodide. So the products here, well, we're going to produce zinc, Zn, and we're also going to produce iodine, okay, I2, or in fact 2 I's, depending on how it goes around. In this case, because iodine is a group 7 atom, it's going to be going around as diatomic iodine. It's in the same group as fluorine and chlorine and bromine, all of which also go around as diatomic particles, so it's going to be I2. So to work out the atom economy, if you remember back from a previous lesson, atom economy is all about the useful products that are gained. Now the useful product in this one is going to be zinc. It's going to be getting zinc out of the iodine. Okay, so we should probably write that the useful product here is zinc. Okay, because we need to know that for our atom economy. So therefore, it's going to be the relative molecular mass, in fact, and relative atomic mass of zinc divided by the relative molecular mass of zinc iodide. Okay, all multiplied by 100. Okay, and that gives us a percentage. So what we have then is the relative atomic mass for zinc is 65. Divided by 65 plus, we've got 2 iodines, and iodine is 127 each. So 127 times 2. All of that divided by that, multiplied by 100, which is going to equal 65 divided by 319. Again, all times 100, which will finally equal 20.376. So we're just going to call that 20.4. Okay, so that is our atom economy. So to work out the half equation at the anode, we need to remember which one is going to be produced at the anode. Now, if you recall from earlier in the lesson, at the anode, we are producing our non-metal ions. So our non-metal ions are oxidized at the anode and they become non-metal atoms. So anode is going to be producing iodine. So first of all, let's think about this. The iodine ion is going to be I minus, and it's going to turn into I2. Okay, now we need to balance that. So our next step then is 2i minus turns into I2. And then I'm going to continue this up here. So 2i minus. Now we need to add or subtract electrons, and in this case we're going to be subtracting them because it's already negative, so we don't want to add more negative charges. So we're going to take away our negative charges. So we're going to say that the negative electrons, in fact there will be 2 of them, our negative electrons are going to be removed from our iodine, and that is going to produce for us neutral diatomic iodine. Okay, so that's our example for our half equation at the anode. Okay, half equation at the cathode. So the cathode is the reduction of metal ions to become metal atoms. So in this case, it's our zinc ion. So Zn. Now, can you recall the charge on a zinc ion? The way we can recall is to know where zinc is in our periodic table. And zinc is a transition metal and is technically part of group 2 for us, so it's going to be a 2 plus ion, remembering that metal ions always become positively charged, and that is going to turn into just simply Zn. Now, one atom becomes one atom, so it doesn't need balancing, and then that will turn into Zn2 plus, and then we need to add electrons this time. I'm going to have to add 2 electrons because it's 2 plus the charge on it, and that will turn into neutral zinc. Okay. So make sure you've got all that information down and that you understand exactly what's working and what happens at each section, at the anode and the cathode, for example. Then I'd like you to move on, pause the video, move on to doing the lithium bromide and the iron fluoride. Now for each of these you're going to need to know which one is the useful item, so I'll tell you about that first before we move on, before you pause the video. So for lithium bromide, the useful item here is the lithium. We would need that lithium for lithium batteries, for example. And for the iron fluoride, the useful product is iron. Okay, so remembering those two things, that it's lithium and iron, the metals that are the useful products. Okay, I'd like you to pause the video and work through those now, please. Okay, so let's go through those. So for lithium bromide, where lithium is the useful products, the products are going to be lithium atoms and bromine diatoms. Okay, so there's a mark for each. And bromine goes around as a pair. So the atom economy is going to be the relative atomic mass of lithium, which is 7, divided by the relative molecular mass of lithium bromide, which is the 7 for the lithium plus 2 lots of 18 for the 2 bromine ions. And so that gives us 7 divided by 67 multiplied by 100. So if you've got any of these workings, you can have a mark for the workings. Doesn't matter if it's this stage or this stage. So either of those. 1 mark for doing some workings, and 1 mark for your answer, which is 4.2. So up to 4 marks so far, 4.2%. So the half equation at the anode is bromine as an ion, so bromide ion, one with a negative charge, turns into diatomic bromine, Br2. So to balance that, we need 2 Br minus, turns into Br2. And then finally, our final equation is going to be that 2 negatively charged bromide ions take away the 2 electrons, is going to turn into a bromide diatom, or 2 atoms together. Okay, so you can have a mark for getting it balanced, okay, which I shouldn't really put here. So mark for having 2, 2 and Br to the small 2, and a mark for having the correct equation, so Br minus, E minus and Br2. Okay, and then the half equation at the cathode, so lithium as a positive ion turns into lithium, a neutral atom. So lithium positive ion, add to that a negatively charged electron, which turns into lithium. So I will give you the mark for that. It doesn't need balancing. So there's 7 marks available here, so give yourself a mark out of 7, please. Okay, so pause the video if you haven't done the next one. Have a go at that before we move on. We're going to move on now to iron fluoride. So iron fluoride, the useful product here is iron. So we're going to get iron atoms and diatomic fluorine, which is F2. Okay, so there's 2 marks there. For our atom economy, again, it is the relative atomic mass of the iron, which is the useful product, divided by the relative molecular mass of the whole compound, iron 3 fluoride. And that gives us 56 divided by 56 plus 3 lots of 19, which is the relative atomic mass of the fluorine. So that gives us 56 divided by 113, all multiplied by 100. So if you've written either of these out, then you have a mark for the workings. And then the answer to that gives us 49.6%, or if you've rounded that to 50%, you can also have a mark. The half equation at the anode, so negative fluoride ion turns into diatomic fluorine. Now, in reality, we actually have 3 fluoride ions because it's iron F3, so I put that in here as stage 1 of our balancing, and that's going to turn into diatomic fluorine. So if you've written this at any stage, you can have that mark. Then if you've gone to say actually that because that's not balanced, we need to turn it into 6 fluoride ions, turns into 3 diatomic fluorines. So you can have a mark for this because 3 and 2, we can't reconcile that because we can't have 3 fluoride ions turns into 1.5 fluorines. We have to double it. So we have 6 fluoride ions turns into 3 fluorine diatoms. Okay, so then 6 F minus, take away 6 electrons, is going to turn that into 3 lots of diatomic fluorine. Okay, so there's quite a lot of marks available for that part. That was tricky. Then for the cathode, we have our Fe3+, because the ion is positively charged by 3, and we know this because the fluoride is F-, okay, because we know it's group 7 atom. and so there must be a 3+ charge on the ion because there are 3 negative fluorides. So that goes 10 times into just regular iron. Now, so to balance that, we need to do Fe3+, add 3 electrons to turn it into a neutral compound of just Fe. So let's see how many marks we've got there. That's a mark out of 8, please. So give yourself a mark out of 8 for that one. Okay, so make sure you've done your corrections for those two. I'm just going to zoom out so you can see them both. So if this text is too small, you can always go back through the video and check your answers and correct them from when I was marking them. Okay, so pause the video if you need to do any corrections. Make sure you've got everything correct before we move on. And now we're going to move on to page 19. Okay, so moving on to extended writing task here. Now, we don't do a whole lot of extended writing in science, to be honest. However, it's really important that you understand that in the exams, quite often they will give you questions that seem like they're only worth a couple of marks each, but actually when you look at it, the entire question might have part A, B, C, D, and so on and so forth. And you might find that at the end of that question, there are 12, 14 marks, all on the same topic, on the same thing. Really one big question divided into sections. You also get 6-mark questions in the exams, which can be quite similar to this as well. They won't necessarily ask you everything on this list, but they could ask you any part of this list. And it's quite common to get questions like this about electrolysis because it's a nice sort of example to give for a 6-mark question. So we're going to be looking at describing the process of electrolysis, and the product of the thing that's being electrolyzed is magnesium chloride, MgCl2. So it asks you to do, first of all, there's a diagram below, which I will just show you. Here we go, there's our diagram. So it wants you to label the diagram using the following words: electrolyte, anode, cathode, DC. So you should be able to do that quite easily. We've done that before. Then it wants you to draw the ions of magnesium, that's Mg2+, and the ions of chloride, which is Cl-, next to their appropriate electrodes. That's important. Then it wants you to draw products that are produced at the cathode and the anode. You need to know which one's which. It also wants you to show the movement of the electrons in the electrodes and the wires. Okay, it suggests some simple arrows to show their direction is enough. Make sure you label those arrows. And then it wants you to write the atom economy for the production of magnesium in this process, which you'll probably want to do at the bottom. Okay, and it wants you to write the half equations at the anode and the cathode. Okay, so parts 5 and 6, there's a section at the bottom. Okay, so you can complete that table for those. So this is an extended writing task. I'd like to pause the video and attempt each of these, and then we will go through that in one go. You can do it in sections if you want, but I strongly recommend having a go at this in entirety from start to finish, because that is how you'll be presented with this in the exams. So pause the video whilst you have a go at that. Okay, so let's go through that. You'll see at the top here, and I've done it in red because that's the colour I usually work in when I'm doing answers, that I've actually ticked off each of these words that I've put on and to label the diagram, and then ticked off each task when I've completed it. So you'll notice there's multiple ticks above and below, key things I've been asked to do. And so I've ticked that off to confirm for myself that I've completed all the required tasks as I go through them, and I know what I have and haven't completed. And I find this to be a really useful method to keep on top of it, especially when you've been given quite a lot to cover in one go. So it's really important you make sure you don't miss anything, and I find that an excellent method to ensure that. So part 1, label the diagram using the following words: electrolyte, that's this greyish liquid; anode, which is this one here, which is positively charged; and cathode, which is this one here, which is negatively charged; and the DC or DC supply. Okay, so if you've got all of those correct, you can have 2 marks. Okay, so 2 marks for part 1. So I'm going to slip it back up to here and give yourself a mark out of 2. Okay, if you have only got 2 or 3 of those correct, then you can have 1 mark. If you only got 1 of those correct, then you don't get any marks. So 2 marks for all 4 correct, 1 mark for 2 or 3 correct, no marks for just 1 correct. Okay, part 2. Draw the ions of magnesium and the ions of chloride next to their appropriate electrodes. So here I've drawn my magnesium ions, Mg2+, next to the cathode, and next to the anode I've drawn the chloride ions, Cl-. Okay, so if you've done them both correctly, then you can have 2 marks. If you've got them mixed up, then you can't have any marks, I'm afraid. So 1 mark for each of those that's correct. So 1 mark for the correct magnesium ions in the correct place, and 1 mark for the chloride ions in the correct place. And they need to be correct ions that you've drawn, so Cl- and Mg2+. Okay, next draw the products at the anode and the cathode. So you can have a mark for each. So I've put here, forms Mg solid. In fact, let's make that so you can see it a bit better. So I've written here that it forms Mg, solid Mg, or just magnesium. So if you've got magnesium, just not with a charge, so neutral magnesium, either forming on the surface of the cathode or dropping down below it, then that counts. Or if you've written it forms magnesium, then you can have that mark. Also, here I've got chlorine gas being formed, gassing off. Okay, so again, if you've shown that chlorine gas, and that's diatomic chlorine, Cl2, is formed, and that shouldn't have a charge, then you can have a mark for that one. Okay, so there are 2 marks available for this one as well, 1 for each of them correct. Now the next part is show the movement of the electrons in the electrodes and the wires. Okay, so it depends on how you've done this. So 1 mark can be for these wires here. So if you've labelled electrons somewhere, then you get a mark, 1 mark for that. Now, to show in the electrodes, what I did, and it looks a bit messy, is you can just about see it here. This is 2E-, so 2 negative electrons going towards an Mg2+ ion. So that's, I'm showing them leaving the cathode and going towards the ions. I've also over here shown them coming from the chloride ion, 1 electron, into the anode. Okay, so you could show it that way and that would get you a mark. Alternately, it would be fine if you put the direction of electron movement in the electrolyte as well. That's another way to earn that second mark, because it's a bit complex doing that way. But make sure you do show somewhere on your diagram an electron coming from a chloride ion into the anode, and 2 electrons coming from the cathode into a magnesium ion. Okay, so 1 mark for each of those. Okay, so that's out of 2 again. Now, part 5 is the atom economy, to show the production of magnesium in this process. So here's our atom economy. You have a mark for your workings out, so that's either this one here or this one here, and a mark for the answer, which is 25.3%. So again, that's a mark out of 2 for part 5. And lastly, the half equations at the anode and the cathodes. And we're going to do, so for the anode, it's, if you've done 2 chloride ions minus 2 electrons turns into diatomic chlorine like this, then you can have the mark. If you haven't balanced it correctly, but you have got the right idea, so you've got chloride minus an electron turns into chlorine atom, then you can still have 1 mark. So it's 2 marks, 1 for getting the correct stuff in the correct order, so chloride minus electrons turns into chlorine atom, and 1 mark for balancing it, which is 2 of each of these 2, the chloride ion and the atom, sorry, the chloride ion and the electrons, turning into diatomic chlorine. So there's 2 marks for that one. And then the next part is for the half equation at the cathode. So Mg2+ turns into Mg, so you have a mark for showing that. And then a second part is to show that Mg2+ plus 2 electrons turns into Mg. So again, 2 marks for this. So for the half equations at the anode and the cathode, our mark is out of 4 now. So the total you can get on this page is 2, 4, 6, 8, 10, 12, 14. So give yourself a mark out of 14 and make sure that you do all the corrections for all the things that you did not get completely correct. So I will zoom out so you can see all that. Okay, so I appreciate that might be quite large and a bit difficult to see, but we have spent time looking at each of those sections of that page separately, so if necessary you can always go back to write your corrections. So make sure you pause the video if you have things you need to copy out here before we move on. Okay, so moving on to the checkpoint question on page 20, which is a question about lead bromide electrodes. Okay, so question A, define the term inert electrode. That's for 2 marks. Part B, the charge on a lead ion is 2+. Deduce the formula of lead bromide. That's for 1 mark. And part C, an electrolysis reaction happens when electricity is passed through molten lead bromide using inert electrodes. Describe what happens in this reaction. So that's a key phrase there. That's your instruction. Include in your answer the name of the products of the electrolysis reaction and an explanation of how the products are made, and that's worth 6 marks. So you can either work in the box on page 20, or you can work on the notes page on page 22, I believe. Okay, so pause the video whilst you have a go at those questions. Okay, so let's go through those. So define the term inert electrodes. There's 2 marks here. One for explaining that inert means unreactive or does not react, and one for saying that an electrode is basically it's just a conductor carrying electric current into a liquid or a solution. So there's your 2 marks there, one for each of those 2 words that you're defining. Part B, the charge on a lead ion is 2 plus. Deduce the formula of lead bromide. Well, if it's 2 positive for the lead, then the bromine is going to be Br2 because bromine is a group 7 atom, and so it will have a -1 charge. So PbBr2 is the correct answer. So part C, this is talking about the electrolysis reaction when we pass electricity through molten lead bromide using those inert electrodes we've just described. So describe what happens in the reaction, including in the answer the name of the products in the reaction and an explanation of how they're made, and that's worth 6 marks. So your first mark might be saying something along the lines of the current causes the ions to move to the electrodes, those ions being the lead and the bromine or bromide ions. So you have a mark for writing that. Then you might say that the lead ions, you don't have to say Pb2+, you'll just say the lead ions or positive lead ions. They're going to move towards the negative electrode or cathode. That's worth a mark. And then you can say that the bromide ions, you don't have to write it like this, you can just say the bromide ions or negative bromide ions are going to move towards the positive electrode or the anode. Okay, so you get a mark for each of those, because it could be up to 3 marks by now. So at the cathode, remembering that cathode is the negative electrode, those lead ions, which are positively charged, are going to gain electrons to form atoms. So if you've written something along these lines about lead ions gaining electrons to make atoms, or neutral atoms, then you can have a mark. If you've written this as a half equation, so Pb2 plus 2e minus turns into Pb, you can have another mark. And then at the anode, if you remember the anode is a positive electrode, the negative bromide ions are going to lose electrons to form neutral atoms. So if you've written a sentence like this, talking about the bromide ions losing their electrons, then you can have a mark. If you've put this into the half equation, which is 2Br minus, take away 2E minus, turns into Br2, then you can have another mark. So there are 7 available marks there, up to a maximum of 6. So if you give yourself a mark out of 6 for that section, and then going back up to part B, a mark out of 1, and back up to part A, a mark out of 2. So that gives us a total mark out of 9 for this section. So if you want to give yourself a mark out of 9, and make sure you've written out any corrections that you need to. Okay, so pause the video if you need to write any of that down, and then we're going to move on to the knowledge check. So moving on to the knowledge check at the bottom of page 20, I'd like to pause the video whilst you complete these questions, and then we'll go through them together. Okay, so let's go through those. Question 1, define inert. Well, it means unreactive or non-reactive. State the charge of the anode, that's positive or plus. The liquid that has free moving ions is electrolyte. The moving electrons are found in either as a current or in the wires in electrolyte. So either of those is fine. You get 1 mark maximum for this question. 2 ways to make ions free to move in a compound is by heating or melting and dissolving. I'll need both for the mark. Redox stands for reduction and oxidation. RED from reduction and OX from oxidation makes the redox word. Metals become positive ions, and the symbol for an electron is a lowercase e with a superscript minus symbol. So give yourself a mark out of 8 for those, please. Make sure you've got any corrections written down before we move on. So moving on to the application knowledge question on page 21. Oxygen is in low supply on any space mission, yet the International Space Station, the ISS, is able to provide enough oxygen for approximately 5 crew members. Explain how the ISS uses water. So explain how the ISS uses water and electrolysis to supply enough oxygen to sustain life. Okay, so this is talking about the electrolysis of water. Okay, so pause the video and have a go and see if you can think about how, maybe draw a diagram that's labelled would be the best way to do this. So draw a diagram, annotate it, label it to show how the electrolysis of water produces enough oxygen for all the crew members. Okay, so let's just go through that. We have here our DC supply with electrons going round the circuit. So if you've identified the electrons, you can have a mark for that. Labelling the cathode as the negatively charged terminal or electrode and the anode as the positively charged electrode. You can have a mark for each of those. We've got water, H2O, as our electrolyte here, and it's going to dissociate into positive hydrogen ions, which are attracted to the negatively charged cathode, so tick that if you got that right. It will also dissociate into negatively charged hydroxide or OH minus ions, which will be attracted to the anode, so tick that if you've got that right. So at the anode here, we'll have O2 gas being produced and collected, so tick that if you've got that right. And at the cathode here, we're going to form H2 hydrogen gas, which is also going to be collected, so tick that if you've also got that right. Now here at the cathode, we have 2 hydrogen ions plus 2 electrons turns into H2, so you can tick that if you got that right. Now over here at the anode, things are a little bit more complex. So 2 of our hydroxide ions, take away 2 electrons, is going to turn into half a diatomic oxygen, so 1 oxygen atom, and 1 water, H2O, okay? However, because we don't really have half a diatomic oxygen, we can double this up, but I want to show this part so that we could work towards this. So 4 hydroxide ions, take away 4 electrons, that's 4E minus, sorry, missed the minus there, is going to turn into diatomic oxygen, O2, and 2 lots of H2O. So if you've written either of those, you can have a mark for that. Okay, so make sure you copy out anything you haven't got correct. You can have a mark with labelling DC supply. And then I would like you to pause the video whilst you get everything written down that you haven't got, and then we're going to move on to the next activity. So today's extension activity is to research how electrolysis can be used to coat cheaper metals with more expensive ones. I'm not going to go through that, that's a research activity for you to do in your own time. And so once you have done that, that would be the end of the lesson. Thank you very much. If you have any questions, please speak to your teacher or email myself. We're very happy to help you. And that's it. Thank you.